Now let's turn our attention to the stoichiometric coefficients, which are coefficients that we place at preceding each compound, reactants, and products in a chemical reaction equation. Now the key with stoichiometric coefficients is to come up with a set of numbers, a set of coefficients that ensure equal numbers of each atom type on both sides of that chemical reaction equation. So as you can see with the oxygen, hydrogen coming together to form water, this reaction as written here is unbalanced. To see this, let's draw a little column here to separate reactants and products, and let's do a quick sum of each atom type, right, on both the reactants and product side. So as we just talked about, oxygen here, O2, right, as written, with no coefficient in front of it, we have simply 2 oxygen atoms on the left-hand side or reactant side of the chemical reaction equation. Similarly, H2 also has 2 atoms. Now, if we compare that to the number of atoms observed over here on the product side, we have a single H2O molecule. Okay? Well, H2O in this case has exactly 2 hydrogen atoms and 1 oxygen atom. Okay? Now, this little table clearly shows us that we have unequal numbers of oxygen atoms. So in order to balance this chemical reaction equation, we need to alter the stoichiometric coefficients such that we have equal numbers of oxygens. All right. Now, in order to do this, what we're going to go ahead and do is change the stoichiometric coefficient in front of water on the product side to 2. All right. And we find that by doing that, we now have the desired 2 oxygen atoms on the right. However, by putting a 2 in front of the water, we've also changed the number of hydrogen atoms. So it's very important to remember to carry out that change. When we introduce a given stoichiometric coefficient, we need to change the corresponding number of all atom types that that coefficient affects. So in this case, we now go from 2 to 4 hydrogens because we have 2 of these sets of 2 hydrogens that are associated with each oxygen in a given water molecule. So in putting the stoichiometric coefficient of 2 in front of water, we've effectively balanced oxygen. However, now hydrogen has become unbalanced. This isn't going to be too much of a problem, though, because we have hydrogen showing up by itself on the reactant side. Therefore, if we introduce a stoichiometric coefficient of 2, we get 4 hydrogens, balancing the number of hydrogens on the product side, and we see that now both oxygen atoms and hydrogen atoms are balanced without having to modify the coefficient of O2. And as hopefully many of you remember, the coefficient, there's always an implied stoichiometric coefficient of 1, which we will soon be neglecting, but for the sake of completeness here, we will go ahead and introduce a 1 there in front of that oxygen. Now, when balancing chemical reaction equations, remember we are introducing these stoichiometric coefficients. Okay? Under no circumstances should we be changing subscripts. So we balance this reaction by introducing our stoichiometric coefficients, right? But never modifying any of the subscripts that show up in either the reactants or products. The reason for this, right, is because, well, if we change the subscript, we are actually changing the molecule, right? So changing subscripts changes the molecule itself. Now, if we change the molecule, we are talking about an entirely different chemical reaction. A chemical reaction that oftentimes will no longer occur. So as tempting as it is to go ahead and just erase a subscript, say, on this oxygen atom and then have a balanced chemical reaction equation, that is something you should never do. That would be similar to changing, out flour in a recipe for making pancakes with, for example, chicken. You're simply not going to get the same reaction. You're not going to get the desired results. Don't do it. Now that we have the same number of each atom type on both sides of the chemical reaction equation, we have what we call a balanced chemical reaction. Right? And once we have this balanced chemical reaction, we're ready to get into the nitty-gritty of moles and stoichiometry calculations, which really comes down to using these stoichiometric coefficients as conversion factors to be able to talk about the relative amounts of each one of these different reactants or products involved in a given chemical reaction.